Hello everybody, my name is Hakim and I am from group B17. So for this presentation, me and my group is doing tray dryer. So a bit of introduction on my group mates. Number one is Ms. Chua, she is the group leader. Me, myself, Fateh, Kashmini, Lokman and Supu. And here is my flow of presentation. So I'll be talking about the introduction and theory. And moving on to the methodology, which will be covered by Mr. Lokman. Results is Ms. Chua. Discussion, we will talk about Ms. Kashmini. And finally, these 2-point recommendation and error and conclusion will be taught by my friend Supu. Ladies and gentlemen, a bit brief on the drying process actually. So drying involves the transfer of liquid from a solid phase to a gaseous phase, meaning that when there's a wet solid, you dry them up, the water converts to water vapor and it moves along to the gas phase. And drying is widely used in, number one is food processing, pharmaceuticals, but mostly in food processing because we want to prevent the growth of microorganisms on food products. So the theory of drying is basically, there are two methods of drying, which is the mechanical method and the thermal method. Mechanical methods involves spinning or rotation of the wet solid. It uses centrifugal force, like in our clothes dryer, one thing. And the thermal method uses heat or hot air to remove excess water. So tray dryer utilizes the thermal method, which is hot air, or using less humid air to carry out moisture from the wet solid to the air. And here is the drying rate curve, as you can see here. So we have several parts, A to B, B to C, C to D, and D to E. So for the first part, A to B is the initial dynamics part, which is normally we do not consider in designing dryers because the period is very short. So, and moving on to the part B and C, which is the constant drying rate, whereby there is enough water or enough moisture to keep the drying at a constant rate. And moving on to the C to D, part C to part D, which is the first falling rate, whereby there is not enough moisture to sustain a constant drying rate. And then D to E, which is the second falling rate. Basically, we have three sections of drying, and for this part, we only consider the constant drying rate because it is very long or very excess compared to the other parts of drying. So that's why our study here relates to, it's a proportional actually. So the drying rate is proportional to the heat constant because we are using hot air and the change in temperature, the inlet and outlet temperature. So with that, I've done my part and I would like to invite my colleague Mr. Lokman to continue on the methodology. Thank
Good
you.
afternoon everyone. My name is Muhammad Hakim. You can call me Lokman. Okay, well, for my part is I want to explain to you about the methodology of this experiment, which is tray drying. Okay, as you can see here, this is a lab equipment that we use for tray dryer. So this is where the wet sand is placed, and then the top of the black is the width, the balance for wet dryer, right? And then from here, this you can see this heater and also the fan, so the air will blow from this to this side. Moving on to the methodology. For first step, we weight the sand, and then after that we spray the sand with the water, and then we weight the wet sand. And after that we place it into the container, which is tray dryer, and then we turn on the fan and we turn on the heater. And after that, we measure the temperature, humidity, inlet and outlet. And then we measure the weight of sand every 5 minutes. And for experiment A, we fix the speed of fan, and we adjust the heater level at different temperature. And for the experiment B, which is we constant the temperature, but we adjust the air velocity and also or the fan speed. That's all. Thank you.
Hi, my name is Chua. I'm going to present to you about the results of our experiment. So as we have mentioned just now, there are two experiments. The first one is on the effect of air temperature. So based on our experiment, we have tabulated these results. From the first column, which is from the time column until the wet sand weight, those are the recorded measurements we have done during the experiment. So using the data that we have obtained, we can find the moisture content and also the drying rate of our experiment. How? By this. These are the calculations and formulas. So for moisture content, we need to first find the difference between wet sand weight and also the weight of dry sand, and divide it by the weight of dry sand. So we got our moisture content for each sample, and then to find the drying rate, we need to find the difference between sample 1 and the consequent sample, and then we divide it by the time difference between the interval which the samples are being taken. Okay, after we found the calculations, we have finalized the calculations, we can further tabulate our results into this form with moisture content and drying rate. So the objective of our experiment is to find the effect of air temperature on drying rate. So we have to plot 3 graphs for this experiment. First, we have to plot moisture content against time. So logically speaking, the moisture content has to decrease with time because moisture is being carried away from the wet sand. And the drying rate versus time graph, where it shows that drying rate should increase with time. And the last graph would be drying rate versus moisture content. As moisture decreases, the drying rate increases. And then for experiment B, is about the effect of air velocity. Basically, it's the same mechanism. The only thing different is that we have changed the manipulated variable. The only thing that we are manipulating is, while we are controlling air velocity, for example, we are manipulating the air temperature, and vice versa. So the graph section will be explained by my colleague Kashwini. So that's me, Chua.
Good afternoon, my name is Kashwini. Today I'll be talking about discussion. There's 2 experiments, experiment A and experiment B. Experiment A is to study the effect of air temperature, and experiment B is to study the effect of velocity. So you can see here the temperature was changed to 2 different values, but the air velocity was kept constant. For both the temperatures, we can notice there is a change in the weight of the sand. The moisture content is decreasing as time increases, therefore the rate of drying increases too. The moisture within the wet sand is being evaporated faster at a higher air temperature, therefore the drying rate will be faster. Higher temperature supplies more heat to the wet sand, therefore increasing the evaporation rate from the sand. Moving on to the next slide, which is experiment B, to study the effect of air velocity on the rate of drying. We can see that the air velocity was changed at 2 different levels, but the air temperature was fixed. For both air speeds, the moisture of the content is decreasing. The moisture content is decreasing as time increases. This shows that the drying rate is increasing. The moisture within the wet sand is being carried away faster at a higher velocity of air. The higher velocity of air supply more air movement to the evaporated moisture, thus increasing the drying rate. Basically, we can say that experiment A and experiment B, the mechanism is the same. So we can see for experiment A, a graph of moisture content versus time was plotted. As time increases, the moisture content decreases. This is another graph for drying rate versus time. As we can see here, as the time increases, the drying rate increases because the moisture of the sand is being removed constantly. Okay. For the third graph of drying rate versus moisture content, as we can see, as the drying rate increases, the moisture content decreases. This is for experiment part B, the effect of air velocity. You can see here the graph is plotted of moisture content versus time. Same goes to experiment A. As the time increases, the moisture content is decreased because the air molecules is being removed from the sand. This is the graph for drying rate versus time. It's the same effect as experiment A. As the time increases, the drying rate increases. This graph shows the drying rate versus moisture content. As the drying rate increases, the moisture content decreases.
Actually. And next up will be on the error that we have encountered while conducting the experiment on tray drying. So the first point here would be the error that we have encountered is on the fluctuation of temperature of the hot air blowing into the tray dryer. So this will somehow affect the drying process in total. So next will be the water sprayed on certain portion of the sand will make the evaporation of the water less and thus affecting the data recorded. Which simply means that on the tray where the sand is, the water should be evenly sprayed all over, not just spraying on certain portions alone. So moving on will be some dirt and heavy dust particles may rest on the weight balance whose span is placed at the top, and thus giving some error value to the weight of the tray. Okay, moving on to the recommendation. So first of all, we have to make sure that all the apparatus being used for conducting the experiment has to be in a proper good condition. So this is so because poor function of the apparatus will affect the final data that's being recorded. And next up will be in order to have an accurate reading, and result, make sure to spread the water throughout the sand, as mentioned earlier. The water has to be sprayed all evenly on the tray where the sand is in. So next will be the average value should be taken to obtain more accurate results. So the values of temperature and relative humidity should at least be taken 2 to 3 times, and the average value must be obtained in order to get accurate data at the end. Next would be on the conclusion. So summing up, in the drying process, two mechanisms is involved here. So firstly, it's the migration of moisture from the interior of an individual grain to the surface, and second one will be evaporation of the moisture from the surface to the surrounding air. So the rate of drying here is, so from the experiment A and experiment B, it is very clear that the rate of drying depends on the air temperature as well as the velocity of air in contact with the material, which is the sand. So to conclude our experiment, so from the we can say that both the air velocity and also the air temperature are directly proportional to the rate of drying of the wet sand. So thank you. That's all.